Alright, we're going to take a look at some other types of equations. First, we'll look at some polynomial equations. So we don't have a whole lot of tools for solving polynomial equations, but we do have four basic ways we can get to the solutions. One is factoring. The next is extracting square roots, completing the square, quadratic formula. So solving a quadratic formula, or excuse me, solving a polynomial equation by factoring. Alright, so taking a look at this one, if I get everything on the left hand side, and then I can factor, have a GCF of 3x squared, and then the x squared minus 16 is a difference of two squares, so that can be factored. And now I've got the three factors set equal to 0, so I can set each factor equal to 0 and solve. So x equals 0, x equals -4, x equals 4. And I just throw a graph up here so you can see why those solutions are what they are. Okay, here's another type. This is a third degree equation. This one we're going to have to do factoring by grouping. And this one's kind of convenient. It's got a GCF of x squared in the first, a GCF of 3 in the second. And then it gives me two binomial GCF terms. I can factor those out. Okay, and then the first equation is easy to solve. The second one, we're going to have to extract square roots. And we are going to get an imaginary solution on this one because of the -3. So go ahead and pull that out. Gives us I square root of 3. Alright, there are some equations that are of quadratic type. In other words, they have the same basic form. Something squared plus that same variable plus a constant. Okay, so if you look at this, you can think of it as x squared squared minus 3x squared plus 2. Or use u substitution to allow you to get rid of the x squared squared. Okay. And that's an option. You don't really have to do that if you don't want to, but it really does help you in calculus later on. Okay, so if I think of it that way, then I have two binomial terms, x squared minus 1, x squared minus 2. X squared minus 1 factors into x plus 1, x minus 1, x squared minus 2, and we'll have to extract square roots. And here are the solutions. So I get x is equal to -1, +1, and plus or minus the square root of 2. Alright, the other type of equation that I want to look at is radical equations. And basically what that is an equation with a radical in it. So to solve the radical equation, we need to isolate a radical, square both sides, and then solve for x. Use one of our techniques for solving for x. The catch on these is that we do have to check every solution because many of them do not work. So add x to both sides, then square both sides. Squaring both sides gets rid of the radical. The right hand side is a binomial squared, which does expand out. Okay, so now we have a quadratic, so let's go ahead and combine like terms and get it in quadratic form. This one is factor friendly, so we'll go ahead and factor and solve. Now, you do have to check the solutions, and you check them in the original equation. So plugging in -3, If I simplify that, I get 1 plus 3 is equal to 2, and that is not a true statement, so negative 3 doesn't work. Plug in the 1. 3 minus 1 is 2, so that one does work. So when you put your solutions in your homework or on your test, you make sure that you do not put x equals negative 3 as one of the solutions. Okay, this example has a double radical in it, and you can only isolate one of the radicals, so you're going to have to do the isolation thing twice. So we need to separate the radicals, get one radical by itself, and then we square both sides. Now when I square this binomial on the right, it gets a little ugly, but just take your time and FOIL it out. So what happened here is I have the square root of x minus 3 times itself, and that's like squaring it, so it gets rid of the radical, so that's where this x minus 3 comes from. And then I have x minus 3 times 1 and 1 times x, square root of x minus 3, so there's 2 of them, and then 1 times 1 is 1. It's a perfect square trinomial. Alright, combine like terms, and we need to isolate the next radical. So I'm going to have to move everything over to the other side. Okay, we can go ahead and square both sides at this point once we isolate the radical. Okay, binomial squared, and then the radical leaves the other side, and don't forget to square the 2 in front of that radical. It becomes 4. Now FOIL that out. Not FOIL, distribute the 4. Combine like terms, and then use a quadratic tool to solve this. This one is factor friendly. And don't forget to check your solutions. Plugging in the 3 works. Plugging in the 7, and the 7 works as well. So both work. Okay, I think I talked about rational equations in a previous video, but we're going to talk about them again. So let's go ahead and multiply by the common denominator to isolate the, or to cancel out the fractions. In this case, our common denominator is going to be x times x minus 2. And what's going to happen when I multiply this x times x minus 2 times this 2 over x, this x and this x will cancel each other. So I'm left with 2 times x minus 2. And in this fraction, the x minus 2's will cancel, so I'm left with x times 3. And then in this last part there's no fraction, so I just have to multiply it out. Okay, so this is where I'm at. Now let's get rid of some parentheses. Combine like terms. Put it in quadratic form. And then use one of your tools. This one is factor friendly. Okay, now when you solve a rational equation, you need to make sure that you check your solutions. Okay, because we are not allowed to have 0 in the denominator of any of our fractions, and neither 4 nor negative 1 would cause a 0 over here, so both solutions are valid. Now here's me showing my check. I don't need to do that. All you have to do on these when you do the check is to make sure it doesn't cause a 0. If you did your algebra correctly, you should have the correct numbers. Okay. Solving equations involving absolute value. Now we've looked at absolute value equations, but these are higher order absolute values. So I wanted to show you one just in case you run across one in a future class. Okay, so this is a absolute value quadratic equation. So we have to look at both. First, you have to isolate the absolute value, as you did in the previous equations. Then we look at both the positive case and the negative case. Now, I've set this one up a little bit differently than I did the other ones before, and it doesn't matter. I mean, you could put this side negative if you wanted to, just like we did in the previous ones. But I went ahead and did it here just so you'd see that we're looking at both the positive and the negative. Okay, so this putting all of this together gives us a quadratic equation, and we're going to get two solutions out of this side. And then looking at the other one, distribute the negative, combine like terms, and I went ahead and divided everything by -1 so that we wouldn't have the leading coefficient negative. Factor and then solve. Okay, and you should check your solutions on this one. There's a whole bunch of answers there. Make sure they all work. So checking x equals -3. That one works. X equals 2. Okay, it looks like that one's not going to work, so we can eliminate x equals 2. X equals 1 works. And the x equals 6 does not work. So it looks like just the first and the third work.